Hey everybody, it's Mrs. Bianchi, and we're looking at a question that does require a lot of stamina to get through it. It's asking, what is the difference between the area of figure A, so that's this entire thing, and the area of figure B? Each grid square represents 1 square foot. So what I thought would be helpful is if we break the thing up. I'm using this red line to break it up. We have to decompose it into shapes that we have area formulas for. So one strategy is to break this up into two parallelograms. A strategy here is to break this up into two different triangles and add them together. So that might be our best approach. So let's try that. Now let's look at this first, this top parallelogram, which I'm going to try to trace in yellow. So it's this one right here. The formula for a parallelogram is area equals base times height. Let's calculate the base on this thing. If we count how long, let's move this out of the way so we get more accurate counting. If we count how long this base is, we get 1, 2, and 3. The base on that thing is 3. And then when we count how tall it is, recall that the height has to be perpendicular to the base. So if we count that, that's 1, 2 units going that way. So the area of that top parallelogram will be the product of 3 times 2, which of course would be 6 square units. Square feet. 6 square feet. Now this appears to be a mirror image of the same parallelogram. And you know how we said that this was 3? This appears to be 3 also, that base. And if we look at the height, that's also 2. So really we have 2 of those. So we can either write the same exact stuff again, or we can say to ourselves, well, we have 2 of those. So our total area is 12 square feet. That's for this entire thing. All right, now what about the triangles? Now they appear to be a little bit different in dimensions, don't they? That does not look like we have a line of symmetry going on there. So let's write down the formula for area of a triangle first. So let's draw a line to separate our work. Our first top triangle, we'll do that one first. So we have half of the base times the height is our formula for triangles. Because remember, triangle is really half of a parallelogram. Let's substitute in the numbers. Now, when you're trying to find the base and the height, you want to find two numbers that are perpendicular to each other. So how about we use this line right here to represent the base of this triangle. In fact, let me trace that in yellow also so you know what I'm talking about. So we're working on finding the area of this triangle right here that I just traced in yellow. Let's move that out of the way so we get a more accurate idea of the dimensions. So if we count, this is 1, 2, 3, 4 units long. Let's substitute that in for the base. The height, recall, has to be perpendicular to the base. So I have this dotted line here ready to go. See, that's perpendicular, and you may be wondering, well, how far out does that have to go? And it has to match up with that vertex that's the farthest from what you're calling the base. So see that vertex right there? This right here, that's the farthest point. So this line that I have here does represent the height. So we'll move it out here and let's count. 1, 2, 3. The height on that is 3. All right, so we have a couple options. We can go straight across because this is an even number and it's easy enough to take half of that. So if we take half of that, we get 2, and we still have to multiply that by this 3. And 2 times 3 would give us 6. So that top triangle has an area of 6 square feet. Now what about the one on the bottom? I'm going to trace that in a different color so we don't get confused. How about green? This triangle right here. Let's find the area of that next. I didn't trace that well at all. All right, but you kind of get the idea. Let's move that out of the way. So let's call this line the base again. And we already counted that earlier, and we know that that's 4. So let's substitute that into our formula. Write the formula again on your piece of paper. Half of the base times the height, or half of 4 times some number that we have to figure out. Whoops, half times 4 times the height, we're going to figure that out. So I have this dotted line over here to help us identify the height. Now remember, the height has to be perpendicular to the base, so it can be anywhere along here, but how long does it have to be? It has to go all the way out to that vertex, that far vertex. So let's move that out of the way so we don't get confused. This would be the height. So let me show it to you here. You can see the perpendicularness of it. And if I slide it over here, you can see that it reaches that far vertex. And it's 2 units in length. Let's substitute that into the formula. All right, and if we finish this up, we can take half of 4 which would be 2, and 2 times 2 would be 4. So that bottom piece is 4 square feet. Now we're still not finished. Add 6 plus 4 to get the area of this thing, and subtract this from it, and you'll have your answer. Good luck.